Hey y'all, so the purpose of this warm-up is for you to be able to see the comparisons, the connections between algebraic form of vectors for this week and geometric form that you learned last week. So number one really is what you guys did last week. It says write or draw the resultant of these two vectors. So I have u and v over here. For u plus v, we know that means we draw our vector u. There's our vector u, and if we center it at the origin, u went over 1 and down 1. And then we're doing plus v, so we take v, we put that on the end of u. So v goes over 2, down 1. So from u, I'm going to go over 2, down 1. And there's vector v. So our resultant of u plus v means starting from the beginning to the end. So it's that purple vector is our resultant. And for number one, it just asks us to draw. So that's the whole point, is to think about our geometric stuff from last week. For part B, negative 3u, same deal. It's negative, so we're going to go the opposite direction. So instead of going down to the right, we'll go up to the left. And then u is just an over 1, up 1, so opposite direction. There's 1, 2, and 3. So negative 3u would just be that entire vector right there, and there's our resultant. So now number 2, this is what we are adding this week, says to write the component form of both of these vectors. So u plus, or for just u and v, so u goes over 1, get my colors, right 1, down 1, so its component form would be 1, negative 1. Again, it's just the coordinates to get to the end of the vector. And then for v, what color was I using for v? Pink. Okay, so v goes left 2, down 1, so they'd both be negative. So its component form would be negative 2, negative 1. And that's all that one's asking. So now 3 says, in number 1, we drew to find the resultants. For 3, we want to use the components to find the resultants. So to find u plus v, it means we have to literally add the component of u plus to the component of v. So we add those together. You just add your common parts. So we add our x's. 1 plus negative 2 is negative 1, comma. Negative 1 plus negative 1 is negative 2. So that means our vector u plus v should be at negative 1, negative 2. And now for number 4, it's going to say check our answers. So let's look back up to the first problem we did. So if we look back up to that first vector that we got, or that we drew, and my drawing's not perfect, but notice that resultant vector, the purple one, is negative 1, should be negative 1, and it draw perfectly, negative 2 down. So from the drawing or from adding the components, you get the same answer. So same deal with that negative 3u. Let's just check it with our components. So negative 3u means we do negative 3 times the u vector, which was 1, negative 1. If we multiply that through, we get negative 3, positive 3. And again, if we go back up to the very first problem where we drew it, notice that resultant vector is negative 3, positive 3. So number 4 just says check those answers. And yes, both of those matched the drawing that we did. Last step, number 5, is now taking our horizontal vertical components, and this is going to really bring us to what we're doing today and relating it to magnitude, and then we're going to be adding direction angle in a second. But it just says find the magnitude of both of those. So all we need to do, pull this over. We know the magnitude is just using Pythagorean theorem. So the magnitude of u plus v squared equals each component added together squared. So 5, take our square root. Magnitude of u plus v is the square root of 5. Same deal with this one. Magnitude of negative 3u will be whatever the square root, negative 3 squared plus 3 squared. So square root of 18, 3 root 2. So that is just simple Pythagorean theorem once you have your components. Hopefully that's helping you guys see the connection between the two. So now for the rest of today, we're really looking at being able to switch between knowing lengths of vectors, directions of vectors and being able to get these horizontal and vertical components.